Hi everyone! In today's tutorial, we'll learn about how to deal with missing values using pandas. In this tutorial, we'll be covering concepts like how to identify missing values, how to count them, as well as how to drop them and impute them. So, let's go! So, firstly, let me import my libraries over here, and I'm importing NumPy because I'm creating missing values in my data frame. Using np.nan, here in my data frame, I'm creating some missing values. Let's see how our data frame looks like. So over here, we have got product categories, sales and returns. And we can see that in sales column, the last value is missing, and in returns columns, the second value is missing. So how do we identify with the help of Python code that where is my missing value? Because let's be honest, this is a very small data set. My data set could be very huge, containing thousands of rows and multiple columns. So for this, we have got some special function called .isnull. So if I write something like df.isnull, what does it do? It creates true and false values corresponding to every single value in the data set. So over here, wherever it is false, it means it's not a missing value. However, wherever it is true, like here, it means there was a missing value in the data set. So over here in returns column, the second value is true. Similarly in sales column, because here was a missing value, that's why the last value is true. And all other values in this data frame are false. Now you can apply this isNull not only to the entire data frame but to also columns. So for this, if I write df.sales, it gives me the sales column. And if I write .isNull in front of it, then it is going to give me the true and false values wherever the values were missing in that particular column. Because the last value was missing here, that's why it's true and rest of the values were false. In Python, there is a opposite of this isNull, which is not null, which indicates wherever the value was not missing. So let me see it like this, that if I write, okay, let me firstly show my df over here. And if I write df.notNull, then notice, whenever it is not a null value, wherever it is not a missing value, then it will give me true. But for the missing values, it's going to give me false. So this was about identifying the missing values. But what about if I want to count how many missing values are there? So here is my sales column. And if I want to count how many missing values are there, I can write something like .isNull, and in front of it, I'll write .sum. Then it sums up wherever the true values were there. It counts how many of them were there and it gives me the total number. So over here, there was only one missing value in sales column. That's why it was returning 1. Similarly, if I write df.isNull over here, I can see that in this entire data set, there were 2 missing values, right? So like one is in sales column and one is in return column. And now if I write .sum, then it is going to give me, corresponding to every single column, how many missing values were there. So, because sales column had one missing value, that's why 1 is written here. Similarly, for the returns column. This isNull function and notNull function are highly useful because they help us in identifying and filtering where the missing values are there in our data. So, let's again have a look at our df. And we see, suppose if we want that give me the rows where sales value was missing. So over here, I can filter using the .log keyword. So I'll write df.log. Suppose I want all the columns. So I'm writing this comma colon over here. And since my filtering condition is that I want the rows where sales column has a missing value. So I can simply write df.sales.isNull. So we know this thing that isNull will be true when only there is a missing value in the sales column. And if we write such kind of true false thing, then in the .log keyword, it is going to return me the rows wherever it was true. So notice it has given me this thing. Similarly, instead of sales, if I write returns, then it's going to return me those rows where the returns column was having any missing value. Let's move to our next concept, which is dropping the missing values. So for this, let me again write my df, and over here we can see that, okay, the missing values are there only in sales and returns column. So to drop the missing values, there is a drop NA function. If I write something like this, currently all the rows wherever any single missing value was available in any of the columns, then all those rows will be dropped by default. So how is this working, guys? So let me paste this code. Over here there is a special parameter called how, and how tells you that how do you want to drop the rows. That is, should it have all the columns has a missing value, or should it have some of the columns, or any of the columns should have missing values. So for this, if by default the value for how is any, it means if any of these columns, of these 3 columns, wherever it finds any missing values, drop those rows. So that's one of the things. If I run this part, it's going to give me the exact same result as above. However, there is another value which this how can take, which is called all. It means drop only those rows where all of the columns are having missing values. So currently there was no row in my data set where all the 3 columns had missing value together at the same time. That's why nothing got dropped. But then why do we want to use something like how equal to all? Because ideally I don't expect these kind of scenarios much where all the columns in the data set, all of them have a missing value, right? This is a special case when we are using it for subset of columns. So let's say by default Python looks for missing values in each and every single column. But what if I care only about 2 columns or 3 columns? Then I can provide a list as a subset. So for this I am writing subset equal to, and suppose I care only about sales or returns column. Then I can provide the list of column names over here. Now what does it do? It looks for the missing values only in these 2 columns, and it will remove the rows where there is missing value together in both of these columns. Currently in my data set there is no such case right now, but then if I run this thing, that's why all of the rows are returned. However, let's assume if this was missing as well as this last value was also missing in the returns column, then this row would have got removed because it would have been searching for missing values in both the columns, sales as well as returns. Now what if I want that it should remove all those rows where there is any single missing values in either sales or returns column? That is, let's say it should remove this kind of row because it has a missing value in sales column. It should remove this kind of row because it has a missing value in returns column. But I don't care about missing values in product category column. For those kind of cases, I'll write how equal to any, because then in this situation it will look for missing values in this subset and it will look for any missing values. It's not necessary that both of them together at the same time should have missing value. It means any one of them can have missing values. So when I run this code, only those rows are returned where sales and returns do not have any kind of missing value. Now there is a special parameter, that is, if we notice our df is currently unaltered. That is, if I run df, then no changes are made in this data frame. But if I want to make the changes in this original data set itself, then in this drop any function, I can write another parameter called inplace equal to true. What it will do, that it will not print anything, but it will actually make the changes in my original data set. So if I run this code now, notice df has now only left with 2 rows. Let's move to our last topic for this discussion, which is fill NA. That is how to impute the missing values. So this is again my df over here, and I have got missing values in sales and returns column. So using this fill NA function, I can write something like df.fillNA, and I can just give it a default value. That is, let's say value is equals to missing. Then it will return that wherever it was encountering a missing value, instead of the NaN, it will replace it with a text called missing. That is with the value which I am specifying in this fill NA command. But many a times I am not trying to replace the missing value with some kind of text. Many a times I am replacing it, maybe let's say if it's a numerical column, then I am replacing it with some kind of mean or median or some kind of other imputation strategy, right? So let's see how do we do it. So I have my sales column, and what if I want to impute the missing values on this? So I'll write something like df.sales.fillNA, Now in this fill NA, what do I do? So here I'll write value equal to df dot sales, and if I want to impute it by mean, then I'll just simply write mean over here. And notice in this last value which was missing, it has returned me the mean of the first 3 values over here which was there in the data set. Similarly, I can save it in the sales column like this, df.sales equal to something like this, and then it would work. Similarly, let's say in the returns column, I don't want to replace the missing value by the average, but I want to replace it by median. Then how would I do it? I'll write something like df square bracket returns, or you can write df.returns as well, dot fill NA. Now in the fill NA, I'll write the value equal to, now what kind of value it will take? It will take df.returns.median. And when I run this code, notice over here, because 678, 670 and 234. So the median for these 3 things is 678. That's why this missing value has been replaced by 678. So that was all about dealing with missing values using pandas. If you like this tutorial, do let us know in the comments below. Until then, see you soon.